Hello everyone, welcome back to my channel Code Genius Riya. So in our last video, we have read first way of using asynchronous communication. Now, in this video, we will learn the second way that we are going to look and is going to be a little bit similar to the database service pattern, and this stuff is going to be seem really bizarre and pretty inefficient. Let me explain you with the example. So suppose here we again focus on introducing new service D for our e-commerce application and just has 3 existing service. More exact idea of what we need from service D is we have like code to show products ordered by a particular user. This is the set precise goal of service D. Now let's try to imagine creating a database that would serve this goal. For this, I have created this database. So it has given the ID of a user, it shows the title and image. And for every product we have ID and product IDs. We could introduce a database. It could be NoSQL or SQL. Doesn't really matter. With 2 separate collections of data. One would be a record of all the different users who have signed up to our application. We don't really care about user email address, name, age or address. The only thing we need to know the ID of a user and show products they have ordered for users collection. I would record ID of every user who signed up to my application and then the IDs of any products they ever ordered. And then to actually know what the title and image is for every product. I could have a separate collection of products where I record the ID, its title and image. We could fill the entries like this. Suppose now we can answer this question can we fill this feature using this database? So yes. Now let's walk through it again. So if I have the ID of a user, let's say the user ID with 1, I need to show the title and image for every product I have ever ordered. So with this database, we would go into our users collection. We find the user with ID 1. We had find the product ID and that have ordered are 5 and 20. And then so we can then go and look inside of our product collection and find ID 5 and 20. Look at the appropriate title and image for both and respond with both those to some incoming request to service D. Well, it's something looks like this that solve the issue. So if we had a database with this structure right here, we could implement service D very easily. Service D would be 100% self-contained. So this really turns into a question of how can we create this database and stick in the relevant information inside there. That is a challenge in its own right. And the reason for that is that if we think about the overall structure of our application right now, service D is never really going to be told about whenever a user sign up, whenever a product gets created or whenever a user orders a given product, because this information is being sent in request to service A, B, C and an output from all that is never making its way over to service D. So right now it's kind of hard to get any relevant information into this database that we just imagined. So that's what we need to solve. We need to think how we can get service A, B, C to tell somehow service D about any time a user signs up, product is created and a user orders a product. And also need to take care whenever service A, B, C communicate out over. We need to figure out how to that communication in some kind of way where service A isn't going to fall if service D is not up. So in other words, if we try to use some synchronous communication, then service from service A to service D, whenever you sign up, Well, that's a dependency. If that request failed for some reason, who knows, service A might crash as well. That's all our requirements put together. Request like to sign up, request to create a product, request to create an order. So how we are going to solve this? Well, that's going to come down to that form of asynchronous communication. So let's go through this process. So we are going to imagine the workflow of how we would get information into a database right here. Here is exactly what would happen. Anytime a request come in to create a product, to sign up a user, or to create or purchase a product, create an order, we are going to have this relevant service emit an event simultaneously describing what just happened to them. Let's first imagine that we put our application for the very first time. We decide to go in our application and create a couple of different products. So we make a request to service B. So here this is for service B. But the goal of creating a product internally, service would say, okay, I got this request. I am going to create a product and save it into my personal database simultaneously. So this is the database for service B. Here is the key. Service B would also emit an event over to our event bus. So that service B is trying to emit an event and reach it out to event bus. And that event might look like have type and data. So it does flow over to our event bus from service B. The event bus would then take that event and send it off to an interested service. So in this case, that would be service D. So it flows down to service D back. It is like emitting back from event bus to service D. Now the service D receive this event. We would have some code inside 3 to receive this event, and service D would say, okay, a product was created with the ID 1 titled pants images of pants.jpg. So service D would take that information and record that event inside of its product table. So that's how we get some information into its database. We are going to rely upon these other services A, B, C emitting events anytime something interesting occurs. So let's now go through the same process and imagine what would happen when a user signs up to our application. So let's imagine a little bit. Later, after we create that product, so suppose like request to sign up, so we have updated some terminology. So for like DB for service A, we have the user collection. So maybe a little bit later, a user comes and sign up to our application. So we get a request to sign up and give to service A. So here the request is going to event bus. So service A would create a new user inside of its user collection, and then it would emit an event over to this event bus. And maybe it would look something like this with a type of user created and a data of ID of user created. So once again, this event would flow over to our event bus along to service D and would send back to service D. Inside of service D, we would have some code to interpret this event. We would say, okay, a user was just created. Well, I am going to save them as a user to my users collection. So in this way, event of event bus pass through the event from event bus to service D. And right now this user has not ordered any products. Sort of maybe just put in an empty array of products ID. Another request to order a product and go to service C. So now service D has its database. So service C would say, okay, I will create a new order inside of some collection and then emit an event. And maybe this event would look something like order created, and it might have some information tied to it like ID of the user and ID of the product that was created as well. So that event flow to our event bus that would come into our service D. So it flows to event bus and it flows to service D. So once again server D would say, okay, order was created, looks like user of ID 1, product with ID 1. So it would update this product ID in the users table and put 1. Now we have database fully populated and service D can instantly very quickly answer what products has a user with ID number 1 ordered. So this is overall asynchronous communication. This is one of the best way that we use to create in further process. So that's why like we have created a database in which we have tables and entries are filled by the help of this service will flow the event to the event bus and event bus will throw back. So that's all about this video. In next video we are going to read the upside and downside of this approach. I hope you will get the point. Thank you.